Welcome to this walkthrough on manually installing Apache Airflow 3 on a Kubernetes cluster. In this guide, we'll go step by step through setting up a production-ready Airflow environment. You'll learn how to integrate Git-based DAG syncing, configure executors, provision storage, set up secrets, and expose the web UI via Ingress. This manual installation approach gives you full visibility and control over your Kubernetes resources. It's especially useful if you need to customize your Airflow deployment or integrate it with existing infrastructure. We'll use Git to sync DAGs, configure KubernetesExecutor for pod-based task execution, and walk through a real example DAG. Airflow 3 introduces several notable improvements over version 2. It strengthens security, improves performance and scheduling efficiency, and includes a more user-friendly UI. There's also improved Kubernetes support and a growing collection of new operators and hooks for broader integrations. These enhancements make it even more suitable for modern container-native deployments. To sync DAGs from a private Git repository, we generate an SSH key pair using SSH keygen. Then we create a Kubernetes secret from the private key. This secret will be mounted into the GitSync container to authenticate Git over SSH. After creating the SSH key, we register the public key as a deploy key in our Git repository. This allows read-only access for pulling DAGs without exposing personal credentials. GitHub has a dedicated section for managing deploy keys in the repository settings. Now, we move to the main configuration file, customvalues.yaml. This file defines how Airflow should be deployed. The most important part is selecting the executor type. We're choosing KubernetesExecutor to make each task run in its own pod. This is more scalable and cloud-native compared to the Celery executor, which requires Redis and additional components. Instead of mounting persistent storage, we'll use GitSync to clone DAGs directly from a Git repository. We configure the Git repo URL, branch, sync interval, and subdirectory. We also reference the SSH key secret and provide GitHub's known SSH host fingerprints to prevent man-in-the-middle attacks. Since we're not using Celery, Redis is no longer needed. We simply set Redis.enabled to false in the values file to disable it entirely and reduce unnecessary resource usage. For the metadata database, we use a PostgreSQL deployment based on the Bitnami legacy image. This is a public alternative to Bitnami's official image, which now requires a subscription. We define the username, password, and other credentials in a Kubernetes secret, then reference those in our Helm config. We expose the Airflow web server using an Ingress resource, handled by Traefik. In the config, we specify the hostname and Ingress class. This allows users to access Airflow from a browser via a friendly domain like airflow.nsa2.com. By default, triggerer pods request 100 GB of storage, which is overkill for most use cases. We reduce this to 5 GI and increase replicas to 2. This allows for better performance with much lower resource usage. Once all configurations and secrets are in place, we run a Helm install command to deploy Airflow into the Airflow namespace. Before doing this, be sure the Git SSH key secret and PostgreSQL credential secret have been applied. To validate everything is working, we include a hello_world_dag.py file in our Git repository. This DAG defines a small pipeline with multiple tasks and uses KubernetesExecutor settings to control pod resources. Once deployed, GitSync pulls it automatically into the DAGs folder in the Airflow container. Once deployed, open your browser and visit http://airflow.nsa2.com or whichever domain you configured. Use the default admin credentials to log in. In the UI, you should see the synced DAGs and be able to trigger and monitor runs through the updated Airflow 3 interface. That wraps up our walkthrough of manually deploying Apache Airflow 3 on Kubernetes. This method provides flexibility and deep understanding of the internals, making it ideal for custom, production-grade environments. From Git-based DAG syncing to Kubernetes native task execution, you're now ready to run Airflow with full control and visibility. Thanks for watching, and see you in the next video.